All right. So today's topic, we're going to start off with the square root property. It is a property that's going to help us to solve equations like this one, where there's quantity squared equal to a number. Okay, a lot of times it's just going to be x squared, but sometimes it's going to be something else squared. Something squared equals a number. And so in this particular case, just starting off with the basic example so you can kind of see where the property comes from, and then I'll give you the general definition. In this particular case, we're looking for the number whose square is 9. Okay? Now, the obvious number, you might say, is 3, right? X equals 3 is a solution to that equation, right? If you take 3 and square it, you get 9. But that's not the only answer. There is also a second answer, and that second answer is negative 3. Okay, so x equals negative 3 is a second answer, because if you take negative 3, put it in there, square and negative, you get a positive, and the answer would be 9 also. So there's actually two answers. They both are the square root of 9, but one is positive and one is negative. Both of them are solutions. Okay? So the square root property, in a general sense, is this. If you take, and I'm going to use the same variables as the textbook, the Blitzer textbook here. If I were to take a variable squared equal to a number, I'm going to say u squared equals d. Okay, d is just a constant, u is a variable or some expression. Then in general, u will be equal to both the positive and negative value of the square root of d. Okay, so that's the general square root property. And it's essentially what we did here. We took the 9, which is our d, take its square root, that gives you the 3's, and then take both the positive and the negative version, okay, the principal square root and the negative square root, and you end up with two answers, okay, or two solutions. Now, of course, we should always put our answers as a solution set when we're solving an equation. So we have negative 3 and 3. Now, if you want to combine those into a single notation, say plus or minus 3, I would be okay with that. All right, and so here you would have the solution set of plus or minus square root of d. All right, so that's the general square root property. Now we can apply this to many other problems that are similar. So something like solving x squared equals 36. Okay, so here I could take x, let's see, equals, using our square root property, you might see it as plus or minus the square root of 36. Okay, just to give you an extra step in there. Now the square root of 36 is 6, and so this is plus or minus 6. Okay, so two solutions, and in solution set form, I could write it shorthand that way. Right? And in fact, we can also do this when the constant is not a perfect square. We could do x squared equals 20. Okay, so in this case we'd have x equals plus or minus the square root of 20. That is the square root property. And then we need to simplify this root. That's just a standard operating procedure in mathematics. There are reasons why we do that, because a simplified root is much easier to work with if we need to do something else with it. And so here, if I think of square root of 20 as 4 times 5, 20 is 4 times 5, then we can take the square root of 4. Square root of 4 is 2. Square root of 5 stays. Okay? And so our final answer in set form would simply be plus or minus 2 times the square root of 5. Right? Okay. Now we can even do this with a quantity squared. It doesn't just have to be an x. Okay, so we could solve some equations like the quantity x plus 4 squared equals 25. And so in this case, the square root property would say, take the stuff being squared and set it equal to the positive or negative square root of 25. Okay, that is our square root property. And then we can calculate that. It's going to be plus or minus 5. And of course, we want to get x by itself. So here I would subtract a 4. Now when I subtract the 4 from both sides, you're going to get a negative 4 plus or minus 5. That actually leads us again to two answers, one using the plus and one using the minus. If I use the plus, negative 4 plus 5 gives me positive 1. And if I use the minus, negative 4 minus 5, I get a negative 9. And so my solution set here is going to be negative 9 and 1. Okay, so again, two solutions. Okay, one thing I do want to point out is that some people call this taking the square root of both sides. And I'm okay with you thinking about it this way, but you do need to be careful. If you were to think about this as the square, A-R-E, square root of both sides, and I'll just start it off with this last example just real quick here. Some people will apply a square root on both sides, and that's fine as long as you remember, because a square root of a square drops off the square, right? So we get x plus 4. But on the right side, you have to be really careful. Whenever you do this with a constant, you have to remember the plus or minus. So when doing this, you must include the plus minus, just like we did over here. Otherwise, you will miss answers, and this is the most common mistake. So if you want to think of it that way, it's okay to. I won't finish that off because it's the same solution. It's okay to do it that way, but you can't forget the plus or minus. Okay? That is the most common mistake when trying to do a square root of both sides. All right? One more example. This one I'm going to run one through where the square is not by itself. So maybe you have something like 5x squared minus, let's say 80 equals 0. And so I can, if I isolate the x squared, I can then solve this. So if I add the 80 to both sides, I can get 5x squared equals 80. If I divide by 5 on both sides, then the x squared should equal, 80 over 5 should be 16. And then I can apply the square root property. And I'll just jump right to the answer here because the 16 is a nice one to take the root of. You get plus or minus 4, right, if I take the square root of 16. And so the final answer, I'm just going to squeeze it. I'll put it over on the left side here. The final answer to that one is the plus and the minus 4. Again, two solutions. Okay?